What the hell's happening here? I'm here. It doesn't go back to the minimize it. Why? You know, again, it's just like either one or the other is minimized. It doesn't make any sense whatsoever. No, the other is minimized. Putting it here, and I can see it getting minimized. No, wait. Oh, wait a minute. What? No, wait. All top is broken. Discord could minimize as well. Yeah, see, if I select it, I can select it, but it's being hidden by this thing. So this one has a layer above dock. Why? This one is normal. So now I switch here and I can switch to that one. It's gonna get. And this layer is still normal. So why? Oh, no, now it's working. No. Now it's hidden again. And the layer is now normal. And this layer is also normal. So why the hell can I not get that on top? Even setting it to bottom doesn't help. That's above dock again. Something is broken. Something is broken. No, again above dock. Nobody gets it. But I can toggle again, apparently, at the moment anyway. What was I looking for? Yeah, standard. This one, Holt's alternative. I'm gonna call it differently. Is a. Yeah. Difference even data is all stored. Not type. So this is a member of this class, as is plot. This plot, as is layer. Event.w. I think that should be event data then now, or yeah, I have an event here, but data anyway. The difference event data gives me the W. This must be the data. Just call it data now. And then here we can do no. Overblown and yeah, of course. Event becomes data. Int if without if. And difference data. Maybe I should just use some enum. But yeah. Might as well use auto here, otherwise I have two of them at the same line. Twice the same type, I mean. So we have it here and then again there, that's kind of silly. Come on. Yeah, there it is. Okay, so the blue line is drawn, and again. And the fourth degree thing is drawn. So I guess that worked. Now I have to do the next one, like to go to algorithm.h. You still have to define a shitload here. For every data type, I still have to define a class. But at least not an event type and not a server, and yeah. Did get a little bit simpler. Okay, so I had a Bezier curve, Bezier fitter here, which I now removed. Oh, there was a reset left. I think the whole... Oh, that's a good question actually. How do I access this? Well, in the other case then, so let's say the reset. Commented this out. So I had a fourth degree approximation curve, which is a Bezier fitter, and I want to call reset on it. So I can have it. I have a trigger here, but okay, that's a good question. Algorithm event type. Okay, no, I don't know. I think I have one callback. I have one callback and I need to access all of those actually, but definitely this one then for a start. The callback ends up in the gradient descent. here. Oh, right. Oh, I can just define a reset. Let's say that I will put that one first. So if event is a gradient descent reset event data, then I don't even need the data itself, so we don't need this line. I just can put all the resets here. Currently only having one. This one, yeah. Can we call reset here? Maybe I add anything else and I can add a reset there. Fortunately now I do have to add this, which is going to be in parallel with, for example, the difference event data, reset event data. So it's just 3 files that play a role here. No, apparently not here. This, what? Not here. Oh no, indeed, not here. Yeah, well, only at this place here. Then algorithm defines it. Okay. So probably need a no, I just define it. So we don't have any of that. I can just use a default. I don't need this one anymore. Then I'm gonna use this public reset and no accessors, but yeah, we need a print on, which is not printing anything, I guess, because we'll never print it, or what? No, I can do it in line anyway. Something like reset event data. It's an empty thing. And the default constructor is going to be that one. Maybe that's already enough. Yep, but I didn't add a trigger yet. So then here I have as well a trigger. I'm just gonna add it here, I think. Trigger reset event type. Which then takes care of this one. Yeah, if it compiles, it works. I don't even have to test it. Does not compile, however. Undeclared identifier reset event type. Oh, wait a minute. No. Everything has to be an algorithm. But it is the default constructed one is the reset. And this one was maybe you should just use this. Okay, now it compiles. Let's get rid of the next one, this one. Plot quotient curve. So we have this, and I want to get rid of it. Only exists once here, so delete here, and then jump to gradient descent. Jump to. All in the same file, same directory. Gradient descent.cxx. So I have to add that here, right? Like that, actually. Which then means I can immediately add it to my reset. And then we covered this one. Furthermore, I'm using it here, which then has to become a trigger. That is line 375. I'll call this one it's a quotient curve. I'm going to pass the quotient, so I'm just calling it the quotient. And then you can do with it what you want. We're going to plot it, but you can do anything. Quotient, okay. And the data that needs to be passed here is, I think I just reference the quotient. Yo. So that means that the algorithm event type now must be allowed to be constructed from the quotient event data. No, so I'm thinking one thing and I'm saying another, or rather I want to say something and then, but I'm thinking another, so no, yeah, whatever. Whatever the type is of a quotient, I have to figure that one out, I guess. Where's the quotient declared? Yeah, auto, very nice. the result of a long division. It's just a polynomial. In what namespace? In math. It's a math polynomial. Oh, we already have that. It's kind of interesting. Or I think I wrapped it actually. Doesn't matter. It's slightly problematic actually. Okay, anyway, let's delete this here. What am I doing wrong here? I'm doing 2 larger than j. That should work. And it takes this one with it. No idea why. Plus it shifts it only 1, so I'm doing something wrong. Else if something to the plot. I'm going to do the same as you. Well, that should work, but I have the feeling I don't have a quotient event data yet. Or do I? No, I don't, right? See, the problem is that in both here and in the quotient event data, I pass a math polynomial. So I can't distinguish the type by just the argument that is passed to the constructor. Yeah, but I need to use a different object here. This one here and that one here. So yeah. Definitely need to make a distinction somehow. I think I'm going to add a enum for the type. I don't want to, I could add it here, but yeah, really. It's already stored in the variant, so that would be a duplicated memory usage here. I'm not going to do that. Even though I want to pause it everywhere here. But yeah, both of these then look extremely the same, right? I could make a class polynomial event data. And then we'll just call this polynomial. is not automatically using the base class constructors. Or constructor, there's only one. Yeah, I don't know if it compiles it works. Let's just try compiling it. It totally does not compile. Called the implicitly deleted default constructor for what? Algorithm event type does not have a default constructor. Which is because data doesn't have one, which is because it doesn't exist anymore. Algorithm event data, as it does. And that should have it if this has a default constructor, provided I added one in the first place. Maxi tags. Error, no matching constructor initialization of algorithm event type. Oh yeah, now I have to pass all those types. I forgot that. What the hell, man? This is inside gradient descent. Oh, this is nonsense. You are already there. No member named fourth degree approximation in gradient descent fourth degree approximation. Event data. Yeah, I renamed it to polynomial. Sure, this must be polynomial. Okay, and I'm slightly worried. One polynomial is not the other polynomial, is it? Those things are constructed. Oh shit. Eh? Have I been so stupid? I think I did. Let me undo this for now. Really? wait a minute. This is just a reference to it. So the construction is outside of this class. Right. See, the polynomial itself has, I think, a constructor, yeah, that you pass the number of coefficients, so it's different. But in the end, it's just a vector, so it just can be a single class. Okay, so this must be polynomial then. And the same for the quotient. Polynomial. So good. The answer, if you ever had a job interview and they ask, I've got it again. What I wanted to say. Damn it, what do I want to say? Yeah, maybe the word, yeah. What? So it's half a joke, but actually it isn't, you know. If they would ask, what does it mean that a program is robust? Then I think you can answer, that means that if it compiles, it works. And now my backspace doesn't work. What the hell, dude? It did not compile, right? Did it? But as soon as it compiles, it will work because my code is robust. Oh yeah, I wanted to make it a joke, so I wanted to use type safety actually, but it's of course not the same thing. So you could, if they ask what does type safety mean, then as a joke you could answer that. If it compiles, it works. Type safety, of course, does have a lot in common, a lot to do with robustness, but okay. Okay, what's this? Trigger event ugly. Yeah, I'm just passing the quotient. Or rather, I'm not passing it. The enum, the event type. The type of the event type, but it's called event type because it already means the same thing. So let's call it not event type, but just event type. But that in lowercase. Now it compiles, which means it must work, although I'm not even sure what I now changed. How can I test it? Quotient. I think that's a two-dimensional thing, or not? Yeah, it's a quotient. So yeah. That's I think the parabola. Gradient descent. Oh. What happened? I went over it, but there's a lot of stuff missing here. Not even sure what this is actually. I don't think my 4th degree polynomial works anymore. Fitting 4th degree polynomial. Events, handle empty. Dude, what the hell? Okay, that's not good. That's definitely not, it works. Definitely not. I hardly changed anything. How can it suddenly not work? I'm having two quotients. Oopsie. Okay, let's make this fourth degree approximation. That one was missing, so that probably is the reason then. Yeah, okay, I recognize this. I think this is this blue line. Now I recognize the colors also for some reason. That the green line is here. The sine one here is the third degree, so this is the fourth degree. This is the derivative, which is third degree, and this is the quotient, which is second degree, so that's a polynomial. And it does get drawn, but it would be nice to actually see an event for it. I think this is the reset because it doesn't have any arguments. Why is it not printed? This is being printed. Strange. So, you know, it prints polynomial event data, and then you can see here that it is the fourth degree. And then this, I don't know. Kind of missing that it has the other polynomial event data. There should be two of these, one for the fourth degree and one for the quotient. It just prints quotient here, but not handling entering the handle of it. What? Why not? What is going on here? Yeah, that output does not look good at all. It looks like I'm having only a single polynomial event data event. Quotient is copy. Would it be this one? Might as well move the trigger up. Why wait so long? We have it here. Call the trigger there. I'm afraid it got suppressed. I think it only handles the first one. Let's run it through the debugger. It's a bit unclear what happens here. Loads of requests. We want to know what happens when this trigger is called in comparison with when that one is called. So we're going to debug into both of them and then see if there's a difference. So let's just stop here. We can do that, I guess. 336. Simply setting it breakpoint. I guess I have to type space a few times. Should happen the next space. Yep. Breakpoint 1337. That's not the file I had expected. I set breakpoint in the wrong position. Ugh. It was algorithm 336, right? Yeah. Stupide. Break there. Run. No. Yep. Yeah, we know you step, you go into this constructor. Very annoying. Really. I want to step into trigger, but not into all the other stuff. See how long that takes. Type is that in place. Let's not step into that. And trigger already. Okay. So we do the following, get the next pointer, and we do a lock, and then we do a while. That calls start handling probably. Start handling does stuff. Nothing. Absolutely nothing. Back to the trigger. Unlock. Quest handle. This is actually a call to handle. So here we should handle it. Do you print it now? Handle the polynomial event data with the 4th degree polynomial. Which then calls callback, which does the drawing. Nobody wants to debug or step into this, but I don't know how else to get there. Okay, so boring. There's so much effort to write fast code, and then as soon as you step into the standard library, it does shit like this. As if CPU cycles don't count. We're in a callback. And then it's not a reset, and it is not difference, but it is a 4th degree. Good. Now we draw the thing. Let's do a step here. Oh no, going back through the whole shit. That is my library. Back in trigger. Stop handling. Whatever. Why? I don't know. I don't not have any clue what it is doing. Next. I don't think this should not be next, right? Okay. We're done. And we got out of trigger. So that trigger did do the callback, yeah? So now we're going to do next, 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 next. Quotient. Now we're calling the trigger on the quotient. So going to take forever again. Data. Oh, in the trigger, okay. Mutex lock while the start handling didn't do anything, but let's look into it anyway. Still not doing anything. Again, the while loop, not request, unlock, handle. Oh, okay, there it is. So this is the quotient, even though it prints nothing now. Why doesn't it print nothing? As if data is empty, but of course data is not empty. We have a callback as well. So it does print it. The callback is done, everything. I'm just confused that this is not printing anything suddenly. Variant, polynomial event data. Yeah, let's go into the callback. Same shit as before. Callback. Is it the reset? Nope. Is it difference? Nope. Is it fourth degree? Nope. Is it the quotient? Yes. Do the drawing. Yeah, so it works actually, but I'm super surprised with this empty handle output debug output here. Why? The type of data was gradient descent algorithm event type. Then what is that printing? Yeah, it printed before. But I mean, the other one is printed, and then to be using the print on of the base class. Oh, okay, I get it. Yeah, no, I get it. Yeah, very good, very good. Yes, I forgot to add that. I forgot to extend it. And the reset is missing as well. Yeah, now we have two of them. And this is indeed a parabola. And also the reset is being printed now instead of an empty handle. Okay, then we can continue with the next one. 1, 2, 3. That one. Yeah, well, what can you do? Derivative curve. Well, it's very close to what we just had. Very close. Derivative. So instead of quotient, we have derivative. So just delete it. And let me go here. Find that thing. The reset. Okay, yeah, so I delete the reset. Or rather, I should not have done this. Yeah, no, you cannot just delete the dirt. Quit. Undo. Delete it, but go to gradient descent and add it there. So add it in the same order as it is calculated. First the fourth degree, then the quotient, and then the derivative. And then the reset, I can add it to the reset, and I don't know why, but it was reset first. Let's use the same order. Derivative curve reset. Maybe the inverse order is more logical, because it is reset. It doesn't matter one bit, of course, but and then now I'm here anyway. I might as well duplicate everything. Gonna look for quotient and then duplicate all the code, but then for what was it? Derivative? No. Oh. Unbelievable, I can't remember that. Derivative, yeah. To duplicate this. And then rename quotient to quotient to derivative. Probably also polynomial, right? Oh, here's also called quotient. Yeah, and the color is probably sine, although we'll run into that in a second. And this, oops, this 10 times is definitely not there in this case. quotient reset. Okay, now derivative below that, derivative reset above it. And here we have the derivative there, and then go to the top again. So this file has been taken care of, I hope. And then here we need, of course, a derivative. And here we need class derivative event data, public polynomial event data. That's it for this file. And then the third and last file calculates it. Now here we have the derivative. So this is the plotting. Benchmark optimization, what are you talking about? I'm not doing any optimization. Why am I calculating the derivative before the quotient? Oh, wait a minute, the quotient should be last. The derivative is the second one. Okay, so this can be put up, put there. Well, if it works at all, then it is faster. I'm not using it. I don't need a benchmark for that. Just usually code is by far the speed of code, or the, yeah, how do you say that? Speed is for 99.99% determined by the algorithm. So if you use a better algorithm, it's that's the way to get it faster. Now, once if you cannot think of a better algorithm, then in the margin you can make it a little bit faster, of course, by tuning the code or optimizing things, adding a cache or cache makes things faster. But in my opinion, that usually holds for code written by bad coders. When I write code, it's all fast. There's hardly ever anything that can be optimized or made faster. I don't write stupid code. I don't write code that is ridiculously slow because it was written in a stupid way, if you get what I mean. So I just concentrate on the algorithm And the rest of the code is already automatically optimized and fast, because that's how my brain works. I'll have to move this. Let's just delete it. But no, I'm not trying to beat anything. I'm just trying to write code that, in my eyes, is good. And then I studied a little bit and I read about what other people do, and my mouth dropped open. So what the fuck are they doing? This is stupid. This is horribly slow. I would never do it like that. But that I'm not trying to beat them or something like that. It's more like I will probably just beat them. I deleted code. I have to add it to gradient descent. The plotting. Already have it here. This is about the derivative. This should be the same as what I already had. Yep. Oh, it's magenta. Well, okay, then I'll use the new line that I just copied. And then I suddenly came to the realization that the order is actually, well, a logical order is fourth degree, then the derivative, which is third degree, and then the quotient, which is second degree. That's the order in which they are calculated. Yep. Okay, so now we have still, I think this is this one, right? This is the derivative. It still works. On the gradient descent stuff, right? Good question. Let's have a look. Well, I usually I just write VIP. I'm doing chess diagram here. I'm not sure if I just did that before or after already starting one. I don't think so. Let's see, this is just drawing, yeah. Drawing circle, drawing text, yeah. Then I started Bezier curves. Symbolic stuff. Symbolic 2, rewrite. Then the chess stuff. Here I start on gradient descent. This is a minimum already. Gradient descent, yeah, gradient descent. So kind of like here. That since end of April, so yeah. The end of April I started, so you should say only 2 months, less than 2 months. Whoa, well, I had expected much longer. Hey, I was working on machine learning, and then I was using GNU-plot as a visual feedback, and I didn't like it, so I started to write Cairo window. Exclusively on, with the idea that in the end I probably will need a better, faster visual feedback. For example, this one is a good one to show something. So then I wrote this, when the window, which allows me to draw vectors and circles and curves and put text in it, and allow me to drag it. I mean, do this with GNU-plot, yeah? You can't. So now at least I have something that gives me fast visual feedback on stuff. And as far as I know, it didn't exist before. At least I couldn't find it. I have no idea, and it's exactly what I want. And if there is something missing, I just add it. But does it have anything to do with machine learning? No. But I wrote it anyway because I just feel like I will need it. And the stupid thing is that, as you can see, this draws curves. And I put an insane amount of time in everything, right? So I can't even tell you the kind of mathematics and stuff that goes into drawing a curve like that. This is built up from Bezier curves, so Bezier pieces optimally in a way that it has an accuracy of 1/10 of a pixel or something like that. But it's not slow. Yeah, it's like very fast. So how does that work? Well, it works because I can't remember anymore. The only thing that matters for me is that I put so much time into it and effort that I'm sure that there is no better solution. And then after that, I don't have to think about it anymore. I don't have to optimize it because you can't make it faster. It just works, and now I use it, and I'll never have to look back at it again. However, there is a part that is not optimal, and that part is when this is calculated, right? I have a function, and the function is mathematics, right? So this is described with a mathematical formula. And then I can draw a curve. But what if you only have a few data points, which is going to be the case of a neural network? If I have a neural network and I do a few samples, then I get a few data points, but I have no idea what the mathematical formula is behind that. So then I want to fit piecewise Bezier curves through data points in a way that satisfies me. And then I went completely overboard. I mean, if I did this for a company, they would fire me with the Bezier curve shit. Let me see if I can find that. I wanted to have... I have too much junk in here because of the gradient descent files. Why can't I... What? Oh, yeah. I think this one... probably what I was looking for. Yeah. So here you have 3 data points, right? I can put those 3 data points somewhere. And then the question is, what is a good curve through it? Well, this is obviously not the best curve. Because, I mean, you have these 3 data points. I mean, there must be a better curve, a more logical curve to draw than this one. But which is it? So I thought, well, let's assume that this is a piece of metal. And well, it's not metal, it's elastic. It's elastic, but yeah, it's also like metal, you can bend it. It's like a spring metal thing. But then, so if you make it longer, then it costs energy. So I put energy into this thing because it is bended, but also because it is stretched. It's longer than, yeah, I mean, I can make it shorter. If you do it like this, it's shorter, yeah? So it's, if this is fixed, this point, so the tangent here is like that, then what is, say, the optimum angle here? If you make the angle like this, then it is a straight line, so you cannot make it shorter. But now there is an infinite bend at this point. So it wants to go in that direction, but within a micrometer, it's bent the whole angle. That costs an infinite amount of energy. So this is not very nice. You can see here the stretching energy plus the bending energy is now 3 million. That's because of this point here. And if I make it a little bit less, it's 4,000 for 5,000. See, so this is already a lot better because now it doesn't have to, isn't infinitely bent here. So I can move this until it is at a minimum 15,000, 6,000, 5,000, 4,000, 3,000, 1,900, 1,500, 14,000, 800. I think it takes them both at the same time, however. So probably, yeah, this is also an influence. So it's not just this one, but it's both of them. So the energy dropped below 1 now. That's a lot better than it was, right? A half. Okay, so in the end, we're probably, the lowest is probably something like here, and then this one, negative, oh god. I think this is a good curve going through those 3 points. That should not be possible, of course. I don't know what's going on. Oh wait, it is the bending weight is at 0, so it doesn't even involve bending. I'm just optimizing the stretching energy now. If you put more weight into bending, then the curve change should be changed. Then you can make it longer, but at least with less bending and stuff like that. Anyway, the formula needed to calculate this energy is, I don't know, 10 pages long. It's absolutely ridiculous big. I don't know, there is no mathematical way to approach this. So I was hoping to get some insight by having it optimized anyway and then dragging this around. And now I have to manually optimize it, and then I can minimize the energy or whatever. But if that happens automatically, I can just drag the points around and it continuously draws the most optimal line. And then I hope to get some kind of insight. But in order to draw the optimal line, I needed a gradient descent thing. So now I thought, well, I'm going to do a machine learning anyway. So let's just write that code now. So the first thing that I'm going to use this for is optimizing the bending and stretching energy as function of a few points. So you get the absolute optimal, visually optimal curve through data points. And then I don't know, meditate on that or something. And yeah, I don't know, it's ridiculous because the only thing that I still have to add to the drawing window thing is the capability of drawing a curve through a few data points. So we just get data points and then we'll draw a nice curve through it. Once I added that, then I'm done with Cairo window. I don't know. Until now, I have to say it kind of feels like it is impossible. But I'm not giving up very quickly. Yeah, maybe. Now I have some visual stuff. I could make videos like some of those people do, the mathematical guys. Some of those videos are very interesting. I saw one that was about the Riemann function, or some complex thing. What's the name of this guy? One blue, three brown, or the other way around? And then he has an animation that looks horrible, absolutely horrible. It just doesn't make any sense. It's like you have a curve, and the beginning and the end is good, and he shows a interpolation between them. Yeah, Grant Anderson. But it's wrong. It doesn't make any sense whatsoever. I don't know what he's doing, but it's really bad. And I've always wanted to do that the right way, that animation. So if you, let's say, compare it with this one, let's say if, let's say you want to show this and the result of, no, that's not neat. You want to show this angle and this, and this curve belongs to this angle, and you want to show this angle. This and this curve belongs to that, yeah? So then what I expect, of course, is that if you go from this one to this one, slowly, that you see exactly this, the correct curve all the time. But it looks in his videos that he has some kind of interpolation where he has just dots on the curve which are linked, and those move linearly to the other place, if you get what I mean. So you have this curve, and then you could say now dot here, dot here, dot here, dot here. You know, that's what he is actually calculating. Then he calculated this curve, and he calculated this curve, and then there is a correspondence between these dots and those dots, and then his animation exists of that each of those dots linearly move to there. So there, yeah, then you go from this curve to that curve, but not in the correct way. That's blatantly clear that he is doing that in the Riemann thing, and it makes it completely useless too, if you ask me. So you have some kind of spiral thing then. So you spiral this, and then you move something and it looks differently. And then he makes an animation, and you see the spiral is just it's just mirroring itself or something. It's horrible. It's completely wrong. So if I would ever make videos like that, I would like to do it correctly. Yeah, so you can definitely, you really can get an insight from the animation. I think I'm gonna stop because it is 1.5 hours later than I really want to go on, and it's an endless endeavor anyway. It's gonna take a few days just to free my algorithm class from the plotting stuff, place everything with events. But I just can't go to bed without playing a game of chess, unfortunately. Yeah, if you don't move in the first 4 seconds, then it's unlikely that you're going to move at all. Goodbye. Next. Control the center. I'm controlling the center now, and controlling the center even more. I have no idea how this opening is called, so I just control the center. Should I do this? Yeah, why not? Probably not good. 3 pawns in the opening? Nah. Can't be good. Oh boy, he makes a French out of it. I really hate French. Maybe it was French from the beginning, but now I recognize it. Something like that. Okay, so 2 times attacked, and I can go here, and he might take it. Or he pushes, then I would be happy. The queen comes here, and he attacks it 3 times. But I'm already having it 1, 2, 3 times defended. I don't think I need my bishop, though. Yeah. No, okay. I think I can do this. This protects again. Yay. Okay, attack 3 times, and it's 3 times defended. No problem whatsoever. Let's could develop my other knight. Okay, that's nasty. I wanted to play this pawn at some point. Casting long is also not extremely appealing. So he stays in the middle. Well, that's interesting. I can do the same, but I'm not. I'm just going to castle like a good boy. I think he's going to castle short. He's castling short. Double the rooks. You can still not move this knight unless he attacks my queen. I want my knight here. Might be problematic. It's at least a lot of moves. And I want to defend this so I can move my knight. I guess I could go one down. Defending this pawn just in case, defending this pawn. So now I can go here, I think. The queen is blocked, so he, well, yeah, I'm defending this enough. So he takes, I take, he take, I take. Don't see the problem there. Actually, I do. My knight is also not defending this thing anymore. He takes my pawn. Oh boy. I'm blind again, as usual. But it takes my knight. Yep. The way out. Is there a way out? What about I take here this pawn? He takes my rook, I take back. He takes my rook, I take back. He can move away, taking my queen. Having a check though. Or a z check here. That's also pretty nasty. Maybe, I don't know. Well, he cannot take it with the rook. I think he takes it like that. I can take here and have my pawn. Isn't it? Yep. This has to defend that. This defends that. I think I can take here. But unless he can take there. And then you have the same story. So he takes again. Not really attacking anything though. Then he would take my knight, for example. Then I have my check and I can take it. Gonna try it. It's probably not good, but I don't have any time left. So the idea was that if now he takes my knight, I take his knight. But he takes, of course, that knight, and then I had this check in between. That was the idea. And then he can take that, And then I probably made it in a few moves. Because, yeah, I didn't think this over past that point. Let's not go here. That is that looks very, very mate. So I'm gonna go down, and this is probably the best place to go to. And then I lose that pawn. Oh, he's going for the kill. Yeah, why not? Yeah, this is finished. Nothing. Cannot defend against this, mate. Should take a spite pawn. I have a pawn. I should go to bed. Yeah, well, let's go to bed, man. This is nothing. Good night. Chess was horrible as usual.